Problem 2. Students randomly selected 217 student cars and found that they had ages with a mean of 7.89 years and a standard deviation of 3.67 years. They also randomly selected 152 faculty cars and found that they had ages with a mean of 5.99 years and a standard deviation of 3.65 years. Using a 0.05 significance level, is there sufficient evidence to support the claim that student cars are older than faculty cars? So we're really focused on, is there sufficient evidence to support the claim that student cars are older than faculty cars or students' cars? So as we look at that, student cars is the first population mentioned. That's our mu1, and we can go ahead and put that in the first spot of H0 and H1. They are being compared to faculty's cars, so that is our mu2, and we know that H0 always starts with equality, and when they're being compared, they're trying to decide if the student cars are older than faculty cars. Older means greater than, and greater than can only go into H1. So H1 is our claim. So let's break down the information that we have. Students randomly selected 217 student cars. Okay, so student cars will be our first population, population 1. And since 217 cars were selected, N1 is 217. They found that they had ages with a mean of 7.89 years. This is from the sample, so this is a sample value. X bar 1 is the 7.89. Now when it says and a standard deviation of, we're still referring to the 217 sampled cars. So in this case, our standard deviation is a sample. So S1 is the 3.67. And now we need to do the same thing for the faculty cars, population 2. They randomly selected 152 faculty cars. As we said, the sample sizes don't need to match. They found a mean of 5.99, so X bar 2 is 5.99, our sample standard deviation. Sample mean. And the standard deviation, again, is a sample standard deviation, so S2. So we're ready to find our test statistic. So we start off with Z equals, and remember the first part of the formula takes X bar 1. So we need to start with 7.89, then we're going to subtract X bar 2, 5.99. Next we subtract the population differences, and if they're equal, the difference of two equal numbers is always 0. Dividing by the error, we start with, in our case, S1 squared, so 3.67 squared divided by the sample size, and then add S2 squared divided by the sample size. On my calculator, I got 4.91041, etc. I'm going to go 2 places to the right of the decimal, so I'll be rounding on the 1, and it is not followed by a number that is 5 or larger, so the 1 will not round up, and I will have 4.91 for my test statistic. Now I'm on to the p-value. It didn't say to use that method, but I've got PV in my box. We always start with the test statistic when finding a p-value. Our test statistic is 4.91, and we're going to be using the z-table. Remember, my test statistic is z equals, so I'm using the z-table. So to use the z-table, we go to the edge and look for our test statistic. 4.91 is not on the edge, though, of the z-table, but a note says to use 0.9999. So we do have area to the left of our test statistic, since that's how the z-table works, but we have a right-tailed test, so we want area to the right. Greater than is the symbol that we used. And so to find area to the right, we take the complement, 1 minus 0.9999 to give us 0.001. Don't forget, once we think we have the p-value we want, we always need to ask ourselves if it needs to be doubled. But we said we had a right-tail test, so it's a one-tail test, and we will not double. I'm ready to answer with my p-value of 0.001. Next, we need to decide if we reject or fail to reject H naught. The rule is if the p-value is less than alpha, reject. I ran out of room, so I just have R for reject. So we're seeing if 0.001 is less than alpha. Alpha is the same thing as the significance level, and we're told to use a 0.05 significance level. If you can't tell if this is a true or false statement, you can remember we can always add zeros after the 5 to compare 0.0001 to 0.0500, and that way a 4-digit number compared to a 4-digit number might be easy for some of you. It is less than, so we do reject H naught. So my claim is H1, I reject H naught, and my conclusion statement starts, the sample data supports the claim that, and as I reread it, it says, is there sufficient evidence to support the claim that student cars are older than faculty cars? So the sample data supports the claim that students' cars are older than faculty's cars. I guess that should be IES, I don't know.